Great, thank you. So the title of my presentation is Design Framework for Adaptive Digital Twins. I'm John. I'm a professor in digital engineering at Cranfield University. So what I'd like to just go over is a process that we developed really to look at adaptive digital twins. So the idea is, how do we adapt the data based on the changes that are happening in the physical asset and processes in an automated way? So we want to create an environment where there's a co-evolution between the digital environment and the physical asset and processes. So we're doing that through ontologies. So the way we've kind of developed this process is we need to be able to capture the data that's changing with time. We also need to capture the software that's changing with time. The software that the data is being processed may also change over time. And I think the other thing is that there might be new software that could be introduced into the digital twin over time. So we need the whole system to be able to cope with these changes. So we've proposed a centralized approach where there's a shared language and we're able to communicate between the different data sources. As you can see in the box on the right hand side here, we're able to communicate between the data sources and different software packages in a structured way, and we're able to automate that flow of changes that are happening across the life cycle. So we've used ontologies because they're semantically representing different knowledge domains. They're able to have the open world assumption, and they're good at reflecting interfaces between different data points. So here you can see an example ontology where we've looked at repair and remote diagnosis. And in that context, you can start to break down the different types of information that you'd like to capture. So it's very much structuring content and providing a common language that can be used for lots of different things, whether you want to search for data, whether you want to connect data to different sources, and whether you want to kind of automate the flow of data. So the framework that we created has two main stages. And I think in terms of evaluating how well the ontology structure is working, we're looking at it from three dimensions. One is variety, in terms of the variety of different types of data that we're interested in. Second is volume, in terms of the number of in terms of the individuals in the ontology that we're updating over time. And velocity, in terms of the number of interfaces that are updated due to the asset's evolution. So we're really measuring those three dimensions and seeing how the digital twin actually copes with changes in data. So I mentioned there's two stages in the design framework. In stage one, we're particularly interested in characterizing the existing system. So it's really about understanding the different hierarchies, understanding the relationships between the hierarchies, and we're trying to define a naming convention. And this is in terms of the different levels in the asset, whether it's component, module, or system. In stage two, we're more so interested in capturing any changes in the system. And we're doing this in terms of different interfaces, different types of new data that's emerging, and creating new classes into the ontology. So that update interface is a key element in stage two. So we're linking data, we're linking software, and we're also able to sort of cope with the adaptiveness element in stage two. So just going into a bit more detail, in stage one, it's looking at identifying the different hierarchical levels in terms of the data and the different data exchanges. And we're actually characterizing those relationships and trying to go into more detail in terms of representing the asset in detail. In terms of those different types of objects, different types of terminology and references that you're going to use. In stage two, it goes into a bit more detail here. So it's really about developing that design flexibility and introducing the adaptiveness in terms of those different temporal attributes, those different relationships between the data points, how they're evolving in terms of the data and software relationships. So you can see we go through 8 stages here, sorry, 8 steps in stage 2. So we applied this concept in an example. So we had a gearbox demonstrator. We looked at retrofitting the gearbox in terms of adding a new screw. So you can see here, and we added a new sensor. So we wanted the digital twin to realize this automatically and to adapt the way the digital twin could capture that. So we recorded the manufacturing activities in a web-based software. We communicated an update to the CAD plugin, reviewed and updated the CAD model, and updated the digital twin to reflect the modifications. So here's just a quick video illustrating how the digital twin was adapting, and we visualized this using augmented reality. So the gearbox, we modified the gearbox by introducing that screw and the new sensor. So that's just here in the video, and the digital twin is capturing the image from the camera system that we have using the augmented reality device, and we're able to feed that adaptation through our ontology. So it's detecting where the change is made, and it's also updating where the change has happened in terms of its reflection about the data and the software that's used in the digital twin. So, we've gone through the stages. So this is just representing stage 1 and 2 in terms of our framework. And as we compared our approach to an SQL-based approach to manage the data, we could see that variety was similar, but there wasn't a need to create, change the schema here. The volume was similar as well, but we were good to see that the data was consistent, and it was easier to manage the data volume changes with the update we made. And also the velocity was faster, but only one interface was needed instead of 2 that we would have needed in an SQL-based approach. So overall, it was a lot more efficient as a process for us. So in terms of some conclusions, we see that there's still a lot more work that needs to be done. We realize that consistency in digital twin development is needed. There's a lot of questions around skills for digital twin development, and I think aligned to that, we've just created a new master level apprenticeship related to this. It's called MSc in Digital and Technology Solutions. And I think also building that feedback loop between the physical and digital artifact is still a hugely challenging area, and there's a lot more work that needs to be done. So I'm conscious of time. I'll stop there and happy to answer any questions. Thank you.